This time on KEI Fabrication when I'm mounting it up. So it worked good. I got the leverage to break the bolt free. So the E is for engineering. Alright folks, I got all my measurements. I don't know if you can see those or not. So I'm going to 3D model a bushing in SolidWorks, and I'll 3D print out a prototype, and then I'll test fit it, and then I will send it to a machine shop and have it manufactured. Alright folks, what I have here is just a quick visual on the two different rotor diameters. Now the Mazda is a 10¼ inch diameter rotor. The Crown Vic rotor is 11½. The actual contact surface of the brake pad on the Crown Vic is like 2 3/8, and on the Mazda it's less than 2 inches. So substantial amount of surface area for braking. And if you look on the end view, you can see the difference in the thickness of the rotors. So a lot more capability to dissipate heat. So again, I'm pretty excited about this whole adventure. Alright folks, this is where we're at here. Remember the last video I was showing you I'm trying to put the big brakes on. So somehow or another I have to get from the Mazda spindle to the Crown Vic spindle, which is a straight smooth bore, because it takes, instead of a tapered roller bearing, it is a straight through type bearing, typical of the later model vehicles of today. So what do I need? I basically need an adapter, a bushing that goes over this and fits securely against this outside diameter and this taper, and then the wheel bearing from the hub will go on. Well, this is kind of what I have here. I 3D printed a prototype that is cut in half to show you the taper and how it fits onto the spindle. So here is my plan. My plan is to create a bushing. I've actually got a solid one here that goes on here. Now this particular bearing actually requires a large heavy-duty washer that goes on here, and then you actually have to torque this down instead of just snugging it like a standard taper roller bearing. So my plan is to have manufactured a heavy-duty washer that goes on, and then the standard spindle nut will go on, and I can show you what that's going to look like here. So what I have here is a washer that will go on and push against the bearing. This bushing is going to be shorter than the actual length of the bearing, and then the spindle nut will go on and force the bearing into the to seat against the back part of the bushing here, and I can torque it up to the recommended torque spec. So that's my plan, and I'll still be able to, if this washer and everything is planned correctly, I'll be able to torque this down to the specified torque for this style bearing, and then still be able to put a cotter pin in to, just in case it happens to loosen up. So that's the plan. So obviously these will be made out of metal. My plan is to make this out of 4140 and then have it machined so it is just a touch of an interference fit. So I'll heat this up. I'll use Loctite bearing locker on here, and I will heat it up, and this bushing will lock itself to the shaft, because this has to be securely located, because this washer will not be holding the bushing on. This washer is intended to put the proper compression force on from the outside of the bearing and the inside of the bearing. So the other thing that was required is there had to be a spacer. So this bushing is incorporating a spacer, so the back side of the bearing for the new hub forces the hub to be spaced out a little different, and that gives me the proper rotor spacing for the caliper bracket, and it also comes closer to matching the offset of that hub, so when the tire is on the flange, the mounting flange, it ends up being the proper stance, if you will, for the vehicle. As a matter of fact, even with this spacer, it's going to be about a 1/4 inch inboard than it would have been with the factory Mazda brake rotor. So here I have the hub on the spindle with the plastic prototype 3D printed bushing in place. There is the space I was talking about that is required to have the hub the proper distance away from the spindle. And then to finish the job off, this washer will go on, and then the standard spindle nut for the Mazda. And that'll apply the proper pressure, and then once this is torqued down, the stock Mazda retaining device with a cotter pin can be utilized. So just trying to get it all to work. It seems like it's going to. I'm going to fine-tune my prototype bushing, and then I'm going to send them to a machine shop and have them manufactured. And that's really the only obstacle to making all this big brake stuff work. Well, we're back in the junkyard. I need to steal a couple more parts off of the Ford Explorer. I ended up ruining the caliper brackets trying to modify them, so I'm grabbing another set. We'll try a different option. So these caliper bracket bolts were wicked tight, and I couldn't get my big cheater bar in there to because the wheels won't turn, the steering column's locked. So I was able to use this 2x6 I just happen to have in my truck to help align the plow when I'm mounting it up. So it worked good. I got the leverage to break the bolt free. So the E is for engineering. Success! I got the caliper bracket off the driver's side. Now we're going for the passenger side. Alright folks, what I have going on here is round 2 of the fit up of these bushings that are going to act as a spacer between the factory wheel bearing for the Mazda and the factory wheel bearing for the Crown Victoria. So the first round, we saw this in a previous video, is printed with a FDM type 3D printer, MakerBot brand, which is a filament deposit manufacturing. And these are great for rapid prototyping, but the surface finish quality and the dimensional stability is not as accurate as you might be for super type machining. So I had access to another type of printer, which is a stereolithography printer, or SLA, and that actually is a laser that solidifies liquid. And this is a very dimensional, stable resin, and the smoothness characteristics are very similar to standard machining. As a matter of fact, I would say that this is probably a 63 finish as opposed to probably a 500 finish or a 250 finish on the MakerBot. And what I did was I made some adjustments based on the first sectioned piece to double check it against the contour that I had to match here, and I noticed that I could make some improvements on my first design to make 100% contact against the factory Mazda spindle to provide as much support to the bearing that is going to ride on this out of the metal pieces once they're manufactured. So this piece was done on the Formlabs stereolithography printer, and it's super precise, and what it did was it really shows me that my new CAD model is way more accurate and a lot more effective in providing that support for the bearing. So what I'm going to do now is I'm going to take the finished prototype from the Formlabs printer. I'm going to install it on here, put the hub on and the rotor, and that'll give me a really precise indication of where my caliper bracket needs to be. And now that I have these 3D, accurately printed 3D models, I am very comfortable in spending the money to have these manufactured at a local machine shop. So now that we have the prototype bushing correctly fitting the spindle to act as a spacer, this is the Crown Vic hub. It goes on directly. Now this is the intended washer to put the proper amount of load on the new style bearings that require a compressive force to make them work. And I'm just going to snug these up for now. So when it's time to put this in for the final time, so you can see that material from that Formlabs printer is very durable and is actually working very well to simulate the finished products. So now I have this precisely located. Now I can do the work I need to put my caliper bracket on to make sure that my brake pads and the caliper is centered appropriately on the rotor. So let's do that. Well folks, there you have it. Thanks to these very accurate prototype parts from Formlabs. This is the final production version basically of the big brake conversion for the Mazda B2200. The caliper bracket is perfectly centered on the rotor. The caliper fits on nice. The way the brake pad interacts with the rotor is right where the factory used to. So the only thing that's preventing me from making this a drivable situation is my production version of these made out of 4140 steel and the brake hose to go from here to the factory Mazda connection. So so this is going to end up being a very inexpensive conversion, except I'm going to have to pay some decent money to have those machined because it's a low production run. There's only going to be, I'm going to make enough sets if I need a spare, have a problem. For some reason I can swap it out and get fixed and get back on the road in a short period of time. And the other thing is it has to be done on a CNC lathe, and I need to find a machine shop that has that capacity. So I'm looking forward to working with somebody to do that, and I'm really looking forward to getting this big brakes on the front, the 8.8 rear in the back, and getting my wheels and tires on all the way around. Next time on KEI Fabrication, we made a decision, and we're going to talk today a little bit about a goal that we have for the Mazda, but we're going to do something with this truck, and I'll fill you in on it in a little while.